Hi guys, it's Miss Gemby here. Welcome to Proving Rectangles, Rhombuses, and Squares. First, this is a warm-up for the day, and we're looking at this quadrilateral and we're trying to decide, is it a parallelogram? And you have to be able to justify your answer. So since I'm looking for parallelogram, I want to look at slopes first. So now, remember M is for slope, so this isn't measure. The slope of AB, I could just count it off of the graph, and the slope of AB is 2, a rise of 2 and a run of 5. The slope of DC is a rise of 2, run of 5. So that's one set of opposite sides that have the same slope or parallel. And then the slope of AD is a drop of 5 and a run of 2. BC is a drop of 5 and a run of 2. So, okay, that's another set. So AB and DC are parallel, and AD and BC are parallel because they have the same slope. And that's your symbol for parallel, is parallel to. Therefore, ABCD is a parallelogram. This is my parallelogram, shorthand for parallelogram. By definition, a parallelogram has two sets of opposite sides that are parallel. Okay, so now let's take a look at the warm-up a little bit closer. When I look at these slopes, I notice that 2/5 and -5/2 are opposite signs and they are reciprocals. Which means they are flipped, reciprocals. Therefore, we know the sides are perpendicular and form right angles. So now I've got a parallelogram with some right angles in it. And I have to think, is it a rectangle or a square? And how would I know? Well, I know it's a parallelogram from the last slide, and I know it has right angles from above. If all sides are congruent, then it is a square. And if opposite sides only, just only the opposite sides are congruent, then it is a rectangle. And I could use my distance formula to prove. All right, so now let's think about proving a rectangle or rhombus or square. We're first going to look at a rhombus because it is a parallelogram with 4 congruent sides. So we first prove parallelogram by showing that both pairs of opposite sides, they have the same slope, are parallel. Then, after we show that it's parallelogram, we show all 4 sides are congruent, which means same distance, meaning we will use our distance formula. Remember, our distance formula is the square root of, I like to write it because we use our slopes and so many other things, our run squared plus our rise squared, square root of that. And it really doesn't matter. I could do my rise squared plus my run squared. Very important to organize your work though. Okay, I want to prove that this is a rhombus. So I've already graphed these points for MATH. I know it's a quadrilateral because it's got 4 sides. First, I want to prove parallelogram. So I'm just going to count my slope, rise and run of AT. Let me get a different color here. So my slope here is a positive 2/3. I'm going to go to the opposite side, count, rise and run is 2/3. All right, so I know that these two opposite sides are parallel. Now I'm going to look at AM, drop 2, run 3. And TH is a drop of 2, a run of 3. Now the slopes are not opposites and reciprocals. They are opposite signs, but they're not reciprocals. So they are not perpendicular, so I do not have right angles where my sides meet. Math is a parallelogram because both sets of the opposite sides are parallel. MA is parallel to AT, is parallel to MH. They have the same slope. And AM is parallel to TH, same slope. Now I'm going to prove all 4 sides are congruent. So I'm looking at my slope numbers. I'm going to look at AT, and I'm going to drop in my 2 and my 3. I actually have my rise and then my run, but remember I discussed it didn't matter. 9, 13 units. Well, I know the MH has the same slope, so it's going to also be 13 units. When I look at AM, I've got a -2 and a +3. Still comes out to 4 plus 9. Still 13, square root 13 units. And TH has the same slope, so it's going to be the same. So I'm making my observation here that all four sides are the square root of 13 units. So math is a rhombus because it is a parallelogram. I proved that in step 1 with 4 congruent sides. And this is my last step, making my statement of what I proved with my mathematics. Let's do another one. Okay, let's look at this rectangle. We can say that the rectangle is a parallelogram with at least one right angle. And we only need one right angle because we can reason it out using our definition of parallelogram. We know that the opposite sides of a parallelogram are congruent. So if this one's a right angle, its opposite angle is also going to be a right angle. And we know that the consecutive angles of a parallelogram are supplementary, meaning in a row. So if I go 90 degrees here, I need another 90 degrees here to be supplementary. I could go 90 degrees here plus 90 degrees here. This is another set of consecutive. Well, and then I end up also with my opposite angles being congruent. Now, to prove that a figure is a rectangle, we're going to show that first it is a parallelogram. That's going to be step 1, same slope. And then one pair of adjacent sides is a corner. It has perpendicular slopes, opposite sides and reciprocals. Got 2 steps. So we want to look and see, is ABCD a rectangle? We need to justify. So first we're going to prove parallelogram. Let's count off our slopes. For AB. For AB, I've got a rise of 3 and a run of 2. Let's get a different color. When I look at DC, I've got a rise of 3 and a run of 2. Okay, so I know that these two sides, they're opposite and they are parallel. When I count BC, I drop 4, I run 6. Same thing with AD, I drop 4 and I run 6. I have this set of opposite sides that are now parallel. So both pairs of opposite sides have the same slope and they are parallel. I know it is a parallelogram. I've proven that. Now I have to show one pair of adjacent sides. One corner has perpendicular slopes. So again, my slope of AB from above was 3/2, 3 over 2. And BC was a -4 over 6, which simplifies to a -2 over 3. 3 over 2 and -2 over 3 are opposite signs. One's positive, one's negative, and they are reciprocals. They're flipped from each other. So this is perpendicular. So I have shown that I do have a corner from AB to BC, right here. This is what I'm looking at. That is a right angle. So ABCD is a rectangle because it is a parallelogram with at least one right angle. Using that definition to make my statement. That's my last step. Okay. Well, now, when we get to a square, remember a square is a parallelogram. It's also a rectangle. It's also a rhombus. So we got a lot of work to do to prove a square. This is one method over here where you can look at opposite sides, prove they're parallel. That shows parallelogram. Then you would do distance formula, show all 4 sides are congruent. And then you would compare slopes to show that one pair of sides of adjacent sides, a quarter, is a right angle. Or, and this is the way I like to do it, you just look at the diagonals and you compare the slopes. Do they bisect each other? I mean, are they perpendicular, congruent, and they bisect each other, having the same midpoint? You still have to do 3 things, but it's with the same. Here you got to look at your sides, and you've got to look at your slopes. Here I'm just going to look at the diagonals. Let me show you what I mean. So now I've got this quadrilateral. That's all I know is that it's got 4 sides. I'm going to draw this diagonal MT and this diagonal HA. MT is in blue and I've got the work for it in blue. HA is in green. I've got the work for it in green. Okay. So the first thing I want to do is I want to look and see if they have the same slopes or opposite reciprocal slopes. The slope of MT when I count it off is a -4, 6. So I go from M to T. For HA, I have to think rise and run. I rise 6 and I run 4. So the slopes are opposite signs and they are reciprocals, meaning that they are perpendicular. So I know that these diagonals right here are perpendicular. Now I want to measure their distances. I'm going to take my slope numbers, plug them in, and I am showing that the diagonals have the same distance or length. That means that they are congruent. I know that MT is congruent to HA. So I've proven that the diagonals are perpendicular. I've proven that they are congruent. Now I just have to look to make sure they have the same midpoint. So let's do the midpoint of MT. And you should have watched that little video. Finding the midpoint is just the average of the x values and then the average of the y values. So let's look at our x values for MT. This is M, here's T. I have a -2 and a +4. Now I'm going to look at the y values. I have a 5 and a 1. -2 plus 4 is 2 divided by 2 is 1. 5 plus 1 is 6. 6 divided by 2 is 3. All right, now I'm going to look at midpoint for HA. So here are my x values, 3 and -1. I'm going to add them together, divide by 2. And then I have 6 and 0 for my y values. -3 plus a -1 is 2. 2 divided by 2 is 1. 6 plus 0 is 6. Divided by 2 is 3. The diagonals have the same midpoint, which means they bisect each other. Now my last step, math is a square because it is a quadrilateral whose diagonals are, we first proved that they were perpendicular, they are congruent, and bisect each other. And we proved that by showing that they have the same midpoint. All right, guys, there you go. We've just proven rhombuses, rectangles, and squares. Join me in our next little video where we look at scalene triangles, isosceles triangles, equilateral triangles, and right triangles. See you soon.